Hey guys, this is the start of 8.3. We're looking at geometric sequences. Okay. It says determine whether the sequence is geometric. Well, yesterday we learned about arithmetic sequences. For arithmetic sequences, we kept adding the same thing over and over again. And whatever we kept adding by, we call it our common difference, or we just use lowercase d. Well, for this one, I'm going to say geometric. I'm multiplying. So I got to keep multiplying by some number. We call it our common ratio, or R. Okay. So for these first few, we're going to say, well, is it geometric? If so, what is my R? Okay. Well, let's look at this one. Do I keep multiplying by something here? Well, my numbers keep getting cut in half, which means that I am multiplying. I'm multiplying by 1/2. So 64 times 1/2 is 32. 32 times 1/2 is 16. 16 times 1/2 is 8. And I could keep going. Okay. What about here? Do I keep multiplying? Well, no, I keep subtracting by 22. Well, subtracting by 22 is arithmetic, not geometric. So that's a not, or that's probably a no. So this one was a yes because I was multiplying. This one was a call it a no. What about this one right here? It looks like all they're doing is adding 0.9. But let me get my calculator out and double check. So one way I can check and see is take the second number, which in this case is 1.2, and divide it by the previous number, 0.3. Okay, so notice that 0.3 times 4 is 1.2. Well, if this is geometric, then I should be able to keep multiplying by 0.4. So I should be able to take 1.2 times 4 and get the next one. That's not the next term. Well, notice if I do the second term, 1.2 minus 0.3, I get 0.9. So 0.3 plus 0.9 is 1.2. 1.2 plus 0.9, that's 2.1. So we keep adding by 0.9, which makes it arithmetic, not geometric. So that one's a no. What about this one? Is it multiplying? Well, it's kind of hard to tell because they're decimals. So again, I'm going to bring my calculator out. Now let's take the second number divided by the first number. So 4.8 divided by 0.8. I get 6. Well, that means 0.8 times 6 is 4.8. But does that pattern continue? Well, let's see. 4.8 times 6. Well, yeah, that gives me 28.8. And what about 28.8 times 6? Yes, that gives me the next one. So I kept multiplying by 8, kept multiplying by 6, and that gave me my next term. So yes, I'm going to put R equals 6. Okay. Now, just like with arithmetic sequences, we have a formula for geometrics. Let me clear all this out. I'm going to write it out here, but I have it on my paper as well. It says that A sub n is equal to A sub 1 times R to the n minus 1. Again, A sub 1 is just the first term. R is what you keep multiplying by. So for 5, A says, provide our rules. So we'll say A sub n equals, well, the first term is negative 5. No, it says each term is 3 times the previous term. There's my R. My R is 3. So it's negative 5 times 3 to the n minus 1 power. What about the next one? It's our part B. It says A sub n equals 54. is my first term, times my r is 1/6 n minus 1. So that's how we do number 5. Okay. Pull the video, we're going to try some more. So figure all those out. So there aren't a whole lot of problems in this one, or different types. So I'm going to do problems 7 and 8 of this section, and then 10 and 12 of the next section. And that pretty much takes us to the end. Stop share so you can see. So again, here's our equation that we're going to use. I need to figure out a sub 1, and I need to figure out r. Well, look at here. First term, a sub 1. There we go. What do I keep multiplying by? Well, I could divide the second number by the first number. If I do that, 21 divided by 7 is 3. I keep multiplying by 3. So my r is 3. Then plug those into here, and I get a sub n equals 7 times 3 to the n minus 1. Okay, so there's my formula, a rule that it asked me for. And then it says, well, find the 7th term. Well, that would be 7 times 3 to the 7 minus 1 power. I cannot do that in my head, sorry. So I'm going to pull my calculator up. I know you can't see it. I'm put it up on the computer. 7 parentheses 3 to the 7 minus 1 power. And it is 5,103. So that and that are my two answers for number 7. I'll do the same thing over here. Again, I'm just going to divide by the previous one, 36, and say, okay, well, the second number divided by the first one. If I just type in 24 divided by 36, I get a decimal. And maybe you can look at the decimal because it's 0.6 repeating and figure out what that is, a fraction. But if not, remember, you can go to alpha y equals on the calculator, put it as a fraction and say 24 on top, 36 in the bottom, and that tells me that my r is 2/3. Okay, so I keep multiplying by 2/3 to get the next number. And of course, there's my a sub 1, so I can plug in and say this is 36 2/3 n minus 1. There's our rule. And then say, well, I want to find the 7th term. So 36 2/3, plug 7 in for n, 7 minus 1. On my calculator, I'm going to type in 36 parentheses 2/3. Alpha y. So I definitely want to put this in as a fraction because I want my answer to be a fraction. 2/3. And then my exponent is going to be 7 minus 1, or I could just put 6. And I end up with 256 over 81. Moving on to the last set. It says a sub 3 is 9, r is 3. Okay? And it just wants a general rule. Well, again, just like last time, this right here doesn't have to be a sub 1. I just have to match that with that number. So if I change this to say a sub 2, I need to change that to the number 2. Okay? Well, in this case, I want to change it to the number 3. So I'll write out in general what I'm going to do. I'm going to change it to a sub 3, which means I need to change this to n minus 3. Now I can plug in and say, okay, a sub n, the a sub 3 is 9, r is 3, n minus 3. And there we go. Over here. So again, what am I going to put? Well, I'm not going to put a sub 1 because I have a sub 4. So I'm going to say a sub 4 r to the n minus 4. Well, again, that gives me a sub n equals, well, a sub 4 is 5, 1/2 n minus 4. And that's it. Hopefully that was a pretty quick and easy lesson. If you have any questions, send me a note.